everyone. Hope you're having a very good day. We are discussing problem of the day for today, which is 16th of January. It is Leetcode 2425. It says bitwise XOR of all pairings. So let's have a look at what the question says. The question very simply says that you are given two arrays, nums1, so nums1, and then nums2, consisting of non-negative integers. So you are either going to have 0 or a number which is greater than that. Then it says there exists another array nums3 which has not been given to you, which contains what? Which contains the bitwise XOR of all pairing of integers between nums1 and nums2. Now what does that mean? They're saying every integer in nums1, so for example 2, is paired with every other integer in nums2 exactly once. Now that means 2 is XORed with 10, gives you 8. 2 is XORed with 2, gives you 0. 2 is XORed with 5, gives you 7. 2 is XORed with 0, gives you 2, and so on and so forth. Each and every number in nums1 is XORed with each and every number in nums2 once. Now the result, so you have 3 numbers over here, you have 4 numbers over here. When you XOR these 3 numbers with these 4 numbers, ultimately you're going to have 12 numbers. So 4, another 4, another 4. So you have 12 numbers over here. Now what you have to return as an answer is the bitwise XOR of all the integers which are in nums of 3. So you have to return the cumulative XOR of all of these integers. Now why I like this question very much is, a beginner, how would a beginner think related to this question? A beginner would just do what is told in the question, right? What, as a beginner, if I was a beginner, what I would have done is I would have done exactly as the question is commanding of me, as the question is requiring of me. I would have calculated 2s or 10, 2s or 2, 2s or 5, 2s or 0, so on and so forth. I would have calculated each and every pair of possibility, and then once I have nums of 3, I would have calculated the XOR of nums of 3 and then returned the answer. Right, that it seems to me the very simplest approach, which takes O of n square in the worst time scenario. But then if you look at the constraints, that's why I have explicitly included the constraints as well. If you look at the constraints, it says 10 to the power 5, which means that if you're opting for an O of n square solution, it would mean 10 to the power 10 time complexity in the worst case scenario, which exceeds 1 second, and therefore your solution wouldn't be able to pass the time limit. It would give you the time limit exceeded error. It wouldn't be able to pass the time limit constraints, right? So let's try to break this problem. It seemingly seems very difficult, isn't it? XOR and whatnot. But let's try to sort of think through a very clear approach, a very easy approach, and let's see how we can very simply, deduce a trick maybe from out of this question, and let's see how we can make it a bit simpler. So the very first example which we have, let me write it down over here. It's 2, 1, 3, and then it's 10, 2, 5, and 0. So let's see what the question requires of us. The question says that you have to calculate 2s or 10, then 2s or 2, 2s or 5, and 2s or 0. And then at the end of the day, what you will be doing is you will be XORing these numbers up as well. So this, XOR this, XOR this, XOR this, isn't it? So let me just write that down as well. XOR this. Just observe very carefully what happens when you have a number. Let's say you have 5 and you XOR it with 5. Let's see. 5 is 101. This is also 101. When you XOR both of them up, you get, yes, you're 100% correct, you get a big fat 0, isn't it? So that means whenever you XOR two same numbers, you get what? You get 0 as a result. So if I just observe over here, how many times do I have 2? 1, 2, 3, 4. And then, so ignoring this particular 2, I'm just talking about the 2 which I'm getting from the array number 1, nums1, right? Nums1. So can't I just cancel all these 2? And then, at this point, you could extend this idea to the number 1 and number 3 as well. So for example, if I have, let's say, 1, 1s or 10, 1s or 2, 1, XOR 5, and then 1 XOR 0. So when ultimately I'm going to XOR these four numbers up, so don't you think that this one is going to cancel this one and this one is going to cancel this one? Why? Due to this particular property which we just talked about, that whenever you XOR two same numbers, they as a result give you 0, isn't it? So what does that mean? This actually lets us know a very important trick. What trick is that? The trick is, see, if you have even numbers over here, if you have even numbers over here, then that means every number which is there in nums1 is going to get XORed how many times? Even number of times. As you can see very clearly, that 2 is being XORed how many times? 4 times. 1 is being XORed how many times? With itself actually. How many times? 4 times. So ultimately it's going to have no effect on the result. So at the end of the day, what will you be returning? You will just be returning the XOR of these numbers, isn't it? Because this is what you are left with. When you say 2s or 10, 2s or 2, 2s or 5, 2s or 0, and then when you cumulatively XOR all of these numbers up, the 2 gets cancelled up, isn't it? So you're left with 10 XOR 2, XOR 5, XOR 0, and that's going to be your final answer. Let's have a look at this particular example as well, the other one. It says 1, 2, and 3, 4. Let's have a look at that as well. So inside of nums1, I have 1 and 2, nums1. Inside of nums2, I have 3 and 4. So let's just take a moment and write what it's going to be. So it's going to be 1 XOR 3, 1 XOR 4, and then it's going to be 2 XOR 3 and 2 XOR 4. And ultimately what I'll be doing is so what I'll do is, for simplicity's sake, I'll just copy these numbers and shift them over here so that it's easier for us to look through them. Alright, and let me just add a little comma over here. Alright, so then what will we do? We'll XOR all of these, all of these, this XOR with this, and so on and so forth, right? And this is one number, it will be XORed with this one. 1 XOR 1, they're going to cancel each other out, right? 3 XOR 3 cancel each other out. 2 XOR 2 cancel each other out. 4 XOR 4 cancel each other out. Ultimately, you don't have anything in the answer. You have a 0 because everything cancels each and every other number out. What does this tell you? Now, why is this answer 0? This answer is 0 because every number in nums1 is being XORed to itself an even number of times, and every number in nums2 is also being XORed with itself how many times? Even number of times. So 3 or 3, yani 3 cancels this 3 cancels this one, and so on and so on and so forth. So this actually tells us that this question can very simply and very efficiently be solved if we consider the parity. The parity in what? The parity in frequency. The parity in frequency. So that means we only have to consider the length of nums1 and nums2. Now what can be the cases? The cases can be even odd, odd even, and odd odd. What we'll do is if the understanding is still not clear to you, let's take a case of each and every example. We'll take the very simplest case for each of these individual cases. All right, so let's first talk about even. Let's say I have 1, 2, 3, and 4. We just saw how 1, 2, 3, and 4 gives us an overall answer of 0. So let me just write that down over here. Let's say the length of nums1 is even, and then the length of nums2 is odd. So let me just, what I'll do is I'll just remove this 4. So length of nums1 is even, length of nums2 is odd. Alright, perfect. Now let's see what happens. So what I'll have is, at the end of the day, 1 XOR 3, 1 XOR 3, and then 2 XOR 3. That's it. What will happen when I XOR these two numbers up? This 3 cancels this 3 out, and I'll only be left with 1 XOR 2. Now, the important thing is, for example, if I had 3 and 4 over here as well, 3 and 4 over here, the length is still even, right? So that would have meant 1 XOR 3, 2 XOR 3, 3 XOR 3, and 4 XOR 3, isn't it? Now when you XOR these numbers up, the important thing is this 3 is going to cancel this 3 out, and then you will be left with 3 XOR 4 over here as well. So XOR 3, XOR 4. So what does that mean? That means that when you have case number 2, when you have case number 2, you know for a fact that you know this particular number is going to cancel itself out at the end of the day. For example, if it was 5 and 6 as well, those 5 and 6 would have cancelled each other out as well, as we saw in the very first example. What were we doing in the very first example? We were just uh, we observed that the number in the numbers which were present in nums1, something happened like this, isn't it? So this was case number 2, and you can very clearly extend this idea to case number 3 as well. Just return nums1 and nums, just sort of like shuffle them up. You can very easily understand this about themselves. So uh, what did we just observe? We observed that whenever we have, let me just go back a little. Whenever we have such a scenario where you have one length as even, the other length as odd, so what's going to happen? This odd is going to cancel itself out, and you will only be left with what? You will only be left with the cumulative XOR of whatever this is. Now let's talk about the very last case that we have, odd and odd. Let's say, what if we have both the lengths as odd? In this scenario, you can very clearly see that the answer is going to be what? 1 XOR 3, which means that we have to consider the cumulative XOR of both arrays, of both nums, of both arrays, isn't it? Does that make sense? I hope it does. For example, let's say if I had 2 over here, 4 over here, 5 over here, and 6 over here, right? Let's say both the lengths are odd. So what will I do? I will do 2s or 4, then 2s or 3, then 2s or 6, isn't it? Then what will I do? I will do 1s or 4, I will do 1s or 3, I will do 1s or 6, similarly for 5s or 4, 5s or 3, and then what? 6 or 3, right? Sorry, 6, not 5s or 6, 5s or 6. So you can very clearly observe over here, this 2 cancels this 2 out, but then this is left, isn't it? This one cancels this one out, but then this is left. This one cancels this one out, but then this is left. And similarly, this 6 cancels this 6 out, but then this is left. This 3 cancels this 3 out, but then this is left. This 4 cancels this 4 out, but then this is left. So what you are doing at the end of the day is 2 XOR 1 XOR 5 XOR 4 XOR 3 XOR 6, isn't it? This is what you are doing. And one very clever way of solving this problem would be, what if we have the cumulative XOR, what if we pre-compute it? So we just have two arrays, right? We just have two arrays, nums1 and nums2. We have nums1 and nums2. So what we can do is we can pre-compute, just like we do prefix sum. The same way, just like we do prefix sum, we can pre-compute what? The cumulative XOR. The cumulative XOR of nums1 and nums2, and then based on the parity of frequency. So let's just make it simple, not the parity of frequency, based on the lengths. Based on the lengths, if they're even or odd, we can return whatever the suitable answers, whatever the suitable answer is. Let me show you how the code is going to be very simple. The code is going to be very simple for that. Let's see how the code is going to look like. Let me share it with you. It's going to be very simple. You can pause at this point and then even code the solution up on your own. How I have done is very simple. What I have done is something like this. So what you do is you check if the size of nums1 is even and nums2 is also even. In that case, just like we saw, all we have to do is we have to just return 0, isn't it? Otherwise, what I have done is I have taken a cumulative variable for nums2, alls or nums2, and then similarly for nums1, alls or nums1. I have calculated uh, the cumulative XOR for nums2 and nums1, and then it's just these are just simple conditions. So if nums1 is even, if the size of nums1 is even and size of nums2 is odd, all I have to do is what? Return the cumulative XOR of nums1. Return the cumulative XOR of nums2. But then if both are odd, return the XOR of cumulative cumulative XOR of both of these. And this question is going to make a lot more sense to you when you do this casework yourself, when you do this particular casework yourself, because I actually did not stumble upon this directly. What I was doing is I didn't get this this parity thing at the very first attempt. It actually took me a little time. Before that, I was actually sort of implementing the nitty gritties of this particular question of doing the casework and all of that. But then do this particular dry run on your own, and then I'm 100% sure then after dry running this question yourself on all of these cases, it's going to make a lot more sense to you, a lot more sense, right? Alright, so that's it from today's POTD video. I'll inshallah see you next time. Until then, take care. Allah Hafiz.